Okay, guys, if you read the text, you'll be confused. If you're patient enough to watch what I'm doing, you'll realize that this is a pretty good unit. All right, let me start here. It says, I'm going to make a tailstock indicator collar. I call it tailstock collar. You read below it, it says analog and digital. All right? Does that confuse you? Does that argue with each other? You bet your ass it does. But let me say this. This is not a curved ball. Just follow the bouncing ball and you'll be pleased with where this goes. Hang on to your sneakers. All right, you're in my scribble sheet, my CAD system. See what it says at the top? 10 EE tailstock indicator collar. That's what this item is I'm going to make. But I'm going to show you what it does. It says analog and digital. I'm going to use an analog indicator to set a digital DRO on my lathe. They'll work in conjunction with each other. Confused? You better be, because I am. Okay, let me show you this. All right, right here we'll start out. This is the tailstock on my 10 EE. This is the housing where the mouse is. This is showing the spindle sticking out. You see it here? All right? And you can see the dimensions, 0, 1/4 inch, 1/2 inch, 3/4, 1, blah, blah, blah. You can see how much stick out there is. All right? All right, let me go over here. I'm showing another view of this. This has got a flat on it, all right? Hang on. I projected the plat here. You can see the plat right here. That's showing the end view of that spindle, all right? Over here. Now let me get rid of that. Okay, I'm showing diameters here. This diameter right here is the biggest diameter in that spindle. This is actually a Morse taper, number 2 Morse taper. I'm showing the smaller diameters here just to let you know what that view is. All right. This collar that I bought this collar, split collar from McMaster Car. You see it here? It says MC, McMaster Car. There's the part number. I'm showing it with the screw in it. Nice husky screw. I put all the hash marks in here to let you know where that screw sits. You see it? Right? Just a little bit extends beyond the diameter, and the same here. Nice husky screw, nice wide split. You see that wide split here and here? All right? Here's a top view of that. All right? Now I'm showing that set screw. I'm showing the bore here. See the bore? And I'm showing the ID. This ID fits the OD of the spindle. Let me do this just to show. I'm going to project.
All right, the delivery person just returned to the post office.
Sorry, I got interrupted. Let me do this. You can see that the ID of this collar fits over the OD of the tailstock spindle. You see that? All right, let me get that out of the way. All right, now I'm going to put this. This is a nice wide collar. I'm going to show you what it is, the width. Total width, 625. You see that? It's 5/8. All right? I'm going to put that collar on this spindle. Hang on, this software is stupider than I am. Now this view was like you're standing over the tailstock looking down on it. This screw is on the back side of the center. Here's the center line of the lathe edge. You follow the mouse? This screw is on the back side, all right? You see it? And I said it was 5/8 wide, you see? Between a half and 3/4, it's 5/8 right there. So everything's in proportion, all right? Let me put it back. Got an idea which way the wind blows. All right, that's all oriented. All these views are oriented to that spindle. Now I'm going to take this and I'm going to turn it 90 degrees this way, okay? Here it is, turned 90 degrees. On it, I'm going to put a 1/4x1. The length will be 3.387. That's approximate, right? And I'm going to screw it. You see here between the bottom of that groove and the OD, I'm going to put a 1032 hole. I'm showing everything in the assembly here. All right? See that? I'm going to give you another view. Same thing here, right? This is your 1030. Here's the ID here. See it? Here's the 1032 screw. I'm showing the little hex, right? All right? And I made individual drawings so we can build this piece in the shop. Put it on. Let me show you what this does now. You see this screw? If I loosen this screw, I can rotate this arm, right? Up or down, right? The target area is somewhere here where the mouse is, right? For the indicator stem, right? Let me do a little something like that.
Here we go.
This is a pain in the ass. Be patient. Just to give you an idea, you know, I'm going to rotate it 20 degrees, okay? Let's see what it looks like. You see it? It's 20 degrees. I could go more. I'm concerned with this area. It's going to miss the bore. You see it? That shape is going to be just right. You'll be able to do what you want. Okay, now I can rotate this whole thing. I'll rotate that 20 degrees. Let's say this was up 20 and it'll show it's ambidextrous. See it? So I can manipulate that sucker. The odds are it'll do what I want. All right? Now let me go down here. I get the same view as here. This is, again, the same drawing. Tailstock housing, graduations on the spindle. And this is that collar with the low carbon steel and the screw pulled against it, right? And this is right here, a pancake magnetic indicator base, you know, little short one. You know what I'm talking about. What I'm going to do is put this magnetic base, this rectangle or square, is the lathe compound. See, it's this lathe compound. I can manipulate it in and out, back and forth, right? All right? So here's what we're going to do. This is how this is going to work. I'm going to first you're going to put the collar on. Christ's sake. I wish I knew how to handle this. Alright. Now you put this on your car, on your spindle. That car, put the car. Shut up. Anyways, the collar is on the tailstock, right? You put your tooling in here, what a drill chuck, drills, whatever, and you come and touch the piece you're gonna work. Once it's you touch it, or touch off, whatever you wanna call it, then you bring this up against here. Let me do that. So the piece is, you know, it's touched off, it's where it belongs. You bring this wave compound, the carriage and the compound up here, and you zero this. See that? You zero that analog indicator. Now that that's zeroed in that position, you go over and you zero the DRO on my lathe, so they both read 0, right? You understand? Now you can retract this and go forward, you know. Then I'll show you in the shop how this is all gonna work. This is kick-ass. It's just when I say digital and analog, I throw curveballs all over the place, all right? I don't know. I'm going to take you guys out in the shop, and I'm going to demonstrate this for you. Right? This has a lot of advantages over the guys that put the digital calipers and make it fitted to the tailstock. That's a pain in the ass. This has some advantages over that, and I'll point them out when we get in the shop. All right? Hang in there. Okay, we're going to show you how we set that. Hang on. Again, you've seen this already. We're going to set the depth from the end of the workpiece, 1 inch 7/30 to the tip of the drill. The tip of the drill here, and it's going to end up 1 inch 7/30 there. We're going to show you how we set it, okay? First thing I want to do, I'm bringing the tailstock. Everything's loose. I'm touching the tip. I can feel it. I'm locked. The tailstock's locked and the spindle's locked. Alright, I'm going to bring this sucker over here. I'm going to bring this indicator to the 0. It's less than 1 revolution. That's right on a 0. 0 to DRO. Okay? Now I'm going to move this in 1 inch 7/30 based on the DRO. I'm only looking at the DRO now. Zero to DRO. Okay. Now I'm going to come back out. When this zeros, that DRO will zero. Just to show you that the movement is correct. Yeah? It's within 2/10 of 1,000. That's not pup tenths. That's 2/10 of 1,000. Now I'm moving this back. And I'm locking the carriage. Whenever I come up to that, no. Is that correct? Yeah. No, it's fucked up. I gotta go back. I gotta go back to the 0. What a schmuck. Don't mind me, you know, my drugs are not up to snuff. You want to take it home, Joe? Okay, now I'm locking the carriage. That indicator can't move. All right? Now let's flip it around. Flip the piece of, we got one side center drilled already. And we got to stop inside the spindle. Wait a minute, that one's already been drilled, I think. Yeah. Don't mind us. We fuck up a free lunch. Alright. Now, no matter what I do, when this hits that, it's 1 inch 730 deep. Okay, Joe, baby, fire this sucker up. Let's see what we got for ours. Too fast. Right about there. Alright? Now it doesn't matter where the spindle is. The trick of this is we can clear the drill easy rather than using, instead of monitoring the there. Now I'm going to drill it till I feel comfortable. Alright, now I'm going to clear it by pulling the tailstock back. I can slide it gently till I feel the bottom. Throw some more. You can clean up the nozzle a little bit more, Joe. Alright, now I'm pulling the tailstock back. A little more oil. Lock the tailstock. That's a long way down, let me tell you. I don't give a shit where that tailstock spindle is. I'm only concerned about this indicator hitting that. Drilling with digging a hole. You get a shovel full and you throw it out. You can't, you know, if you drill too much and you choke up the drill, you end up with a broken drilling out. Alright, here we go. Choking now as it gets deeper. We're getting there, Pedro. Stop looking at that dial indicator. Guys, I'm signing off. You know the routine. Save the world, pay it forward. All right? Hang in there. like I always say, thanks for watching. I'm gonna make like the good shepherd and get the flock out. See ya.